Welcome everyone, and thank you so much for joining us on this Wednesday morning. That's all from me this morning. So I'm going to hand over to our speaker today, Tormod Steen from Oceanize. I'm just going to stop sharing. So Tormod, whenever you're ready.
Thank you. I will start sharing my screen. Yes, then I'll start. First of all, thank you for the invitation. The invitation to tell you about our goals and our achievements in capturing the value of marine plastic waste in Norway. Norway is a country with a lot of fishery and aquaculture, and these industries use a lot of plastic. And we have found processes to try and collect and capture this value. I am working as a communication and a project manager here at Oceanize. So that's what I'll do. I will start tell you a bit about who we are. First of all, Oceanize is the mother or the parent company of two other companies. I will try to. No, you can't see my pin. The first company is Container Service Oceanize. That is a company with roots back to the 70s and is operating mostly as a waste facility, receiving all kinds of industrial waste. A part such as metal or paper of this waste we send for recycling by other companies in Norway. The plastic, on the other hand, we keep for ourselves for recycling by this other company, Norprek, Norwegian Plastic Recycling. Container Service Oceanize is not only equipped for receiving the plastic waste, but is also equipped for traveling around the entire coast of Norway, collecting the resources. Norprek is the company receiving the plastic and recycling the plastic by washing, filtrating, melting, and extruding the plastic, making a plastic granulate. I will tell you a lot about that later. Oceanize, the parent company, has two main tasks. One is establishing a way to track the plastic resources, and the other job is to find the right downstream solutions for the recycled plastic. In other words, find the plastic producers that can use and will use the recycled materials in new products. This circular chain that Oceanize is representing looks a bit like this. In the top, we find the plastic consumers, and the companies you see here are mostly aquaculture companies in Norway. That produce salmon in big fish cages made of plastic in the sea. Then we collected by Oceanize Container Service when the plastic is no longer meeting the demands, or we work together with other waste facilities to get the plastic. The plastic then goes to recycling by Norprek, and then is sent to Norwegian producers that use this plastic in their products. And then dealers sell the products back to the consumers. And in some examples, we have made a complete, perfect value chain with plastic going from the aquaculture and back to the aquaculture. That is if you study the circle chain clockwise. What's interesting is if we study it counterclockwise, because that would represent how we need to work to make this circular value chain work. We need the consumers to demand products from the dealers that first of all is recyclable. For the plastic part, that means not made of many different plastic types, and they need to ask for products made out of recycled plastic. Then the dealers have to go to the producers and demand these products, and the producers need to demand a high quality product from us, and we need to demand pure fractions from the collectors. So how do we keep the resources in circular value chains? In the middle picture, you can see one of these fish cages, really big plastic rings with a diameter of up to 160 meters. And one of these rings contains about 40 tons of plastic. After some years in the sea, exposed to UV light and nature forces, these cages no longer meet the standards. And these standards are critical to secure the health of the fish in the cage and prevent the fish from escaping and blending with the wild salmon. So when they no longer meet the standards, they need to change them out. And the old cages are then waste. And until we started recycling, the solution were incineration or landfill, and sometimes export to other companies in other places in the world. What we do when the plastic resources no longer can be used, we travel the entire coast of Norway, dragging the fish cages on shore. We separate the different parts of the cage. The nets, the walking fields, the tubes, everything gets separated, and we grind it down. The tubes are filled with the EPS that we press, and we put this in separate big bags and then take it to our facility for recycling. So when the grinded resources arrives at our facility, we start the recycling process. And this is the process where we produce granulate, like in the top left picture. This is a granulate made of polyethylene, and all of the plastic we produce goes through our lab. And the woman in the middle, a woman named Molly, she runs tests on all the plastic we produce, so we can find the right downstream solution. For example, the plastic from the tubes of the fish cage, we produce a plastic granulate, and we sell it to a company named Plasto here in Norway that produces new walking fields for the aquaculture. So that is one example of a complete circular value chain. Here are some other customer products made out of our recycled products. In the top left corner, you can see some chairs. They are made of recycled ropes from us. A shopping basket. The bench in the middle is quite interesting because it is made of ownerless plastic. Plastic collected by beach cleanup groups then recycled by us, and is then turned into this bench. And the resources in this plastic bench is completely trackable. So it has a QR code, so you can check where the plastic is collected, and it tells you what to do with the bench when it's characterized as waste. You can also see some furnitures in the top right corner, and a really good story is if you're in Norway or in Sweden and decide to go to McDonald's, you get your food served on a tray made out of recycled ropes from us. Okay, I would like to elaborate the recycling process. When the plastic enters our facility, we start by washing it. And you can see the washing line in the left picture. It's a floating bath with some engines that run some spoons blending the plastic. This will make impurities like sand, biomass, and also PVC sink. We use only pure water in this wash line. So the plastic we want to recycle then floats. We don't want PVC because when we melt it, the chlor reacts with hydrogen and then turns into salt acid. Then the clean plastic is transported to the granulation line you see in the middle of the picture. Here it runs through a metal detector, then being shredded into even smaller pieces before the plastic is melted through a melting screw. Then the plastic is filtrated and then extruded, which means we push out a thin plastic string, and then it gets cut into granulates. Before it gets cooled in first water, you can see in the right picture, and then being blended in a big silo before packaging and sent to plastic producers. This line is designed for recycling a plastic fraction called HDPE, high density polyethylene. But we have also run it on many different other fractions, such as ropes, such as beach cleanup plastic. But this year we are doubling our capacity and investing in a second line, which is designed for recycling ropes. Okay, the laboratory test. In our lab, we test the plastic for density, moisture, and the most important test we do is melt flow index or melt flow ratio. This is a test where we, in a machine, melt a small piece of plastic and then check how many grams are being pushed out of a tube in 10 minutes. And this tells us how long now, how the plastic melts. And it's a very important indicator for plastic producers, because some are running blow molding of products, some extrude pipes, some are rotation molding, and they need to know this to know if the plastic fits in their machinery. Also, it makes us able to control our process, because we know the melt flow index of for example, polyethylene. And if we get a sudden drop of the melt flow, this could indicate impurities, or it could indicate that many of the polymer chains are broken. So the chains are shorter, then it will float more easily. Yes. I will then move on to our goals. I told you about our first line designed for HDPE pipes, and we have a second line coming up this year designed for recycling ropes. And you can see our goals. We have a goal of totally 6 lines. One of these lines has the capacity of recycling up to 3,500 tons of plastic every year. This year we can recycle up to, now we are able to recycle up to 7,000 tons of plastic. We are not quite sure which plastic fraction who is the next, because we have to know that we have a sure income of the plastic resources before we start investing in a line. So we don't know if the nets will be the next line or big bags will be the next line. We have to see what income of plastic waste we have. We also have some sustainability goals. First of all, the climate goals. For each kilogram of plastic we recycle, we reduce 3 kilograms of carbon dioxide by preventing incineration. And we are reducing 2 kilograms of CO2 by reducing the need for virgin plastic production. And I have done some calculation. 6 lines means 20,000 tons recycled plastic, approximately. And that means 100 million kilograms of CO2 spared. We also have environmental goals. We want to reduce plastic in landfills. In Norway, still a lot of good, high-quality plastic, which can be recycled, are being put in landfills. The picture you see, I took in a landfill in a town called Ålesund a couple of months ago, and it's a huge mountain of high-quality ropes. They've just put the dirt over. We also work with other waste companies. We are helping them to sort the different plastic fractions, and we are recycling ownerless plastic from beach cleanup groups. We also have a goal to track the resources, to make a complete circular value chain for the plastic. We need to find where it's leaking, and to do that we need to track the resources. We also have goals about economic growth. In Norway, the government has a goal that the production in the country and how much we produce is supposed to be bigger than the production of waste. And we do both. We reduce the amount of waste by characterizing waste as a resource and making it able to use again. And we also are establishing a whole new industry in Norway for recycling plastic. Yes, we have a goal that we want to lift a new fraction every year from landfill and mainly to material recycling. We have lifted the tubes, the HDPE, from landfill, and now we are material recycling it. And we have lifted ropes to material recycling, and we have lifted nets to energy recovery. The reason why we can't recycle the nets is because it contains an impregnation that makes it characterized as dangerous waste. So we can't establish dangerous waste in circular value chains. Yes, partnership for the goals. We are working with a lot of partners to reach our goals. I have shown you our circular chain. We are working upstream to get the resources. We are working downstream to find the producers. We are working with the dealers and producers in how they produce and design their products to make it recyclable. And we don't want them to produce a product with a lower quality using recycled materials. So we are working a lot together to make them make products with the same quality, but with recycled plastic. Yes. I'm getting close to the end now. I guess there's a lot of smart people out there listening to this webinar. So I have a problem, and I'm hoping some of you may help me solve the problem. You have probably seen this this picture before. I borrowed it from Ellen MacArthur Foundation. And if you follow the blue side, the right side of this illustration, we can see how we should work in the circular economy. From when a user has a product that no longer meets the demands, the best thing is first of all maintaining the product, then reuse or refurbish, and then eventually recycling. So by this diagram, reuse is better than recycling, and recycling is better than energy recovery. But for example, we are collecting nets from the fishery and aquaculture, and we have the opportunity to send them all around the globe for being reused. What we do is send it to incineration because it's dangerous waste. But this diagram tells me it's better to send it all around the globe for reuse. But what happens when a net, for example, in Malaysia is characterized as waste? What do they do with it? These are really difficult questions, and I'm hoping for some answers. This is the last slide. First of all, I would like to thank you for listening to me, and I will end this slideshow by showing a picture of my daughter holding plastic granulates produced by us, because for me this is what sustainability eventually is all about. It's a use of the resources today that meets our demands without making problems for the later generations. And plastic is made out of non-renewable energy sources, so we have to make a way to establish them in circular chains. Thank you.
Thank you so much, Tormod. It's incredible to hear the work that Oceanize does, and particularly the role that it plays within the circular economy and providing end-use markets for otherwise what would be considered waste. I see we have a few questions in the chat already, and then perhaps if we have time, we can come back to the question you posed, which almost sounds a bit like it fits in with the sort of action plan approach that SST is working on. But first, the questions. We have a question in the chat here from Amanda that says, do you carry out any testing on mechanical properties, impact hardness, tensile strength, etc.? I think
we do test like that also, but we do it by bigger laboratories doing the test for us. We have done it so we can produce a complete data sheet for our recycled products, which is very important to first of all show everybody the quality of our recycled products, but also for the producers.
Okay, and in terms of data sheets, is it a case of just quantifying what raw product is coming in and what's going out, or kind of any brand audits, or what kind of information is captured in the data sheets?
In the data sheet, for example, we have a data sheet for recycled ropes, and it tells how much polyethylene is in the rope, how much propylene is in the rope, what is the melt flow, what is the density, what is the Sharpies test, different tests.
Okay, thanks. And then I see Amanda goes on to suggest a few more questions, saying, very interesting presentation, thank you. How do you propose to track the resources around the system?
Oh, that is a very, very difficult question, because it demands a whole lot of cooperation through the entire circular chain. And we need to sort out what information do we need to track. And then we are working only on the plastic. But what about all the other resources we use, such as paper, metal? The consumers not only use plastic, they use many other products. So are we going to find a solution for just plastic, or do we need to cooperate with other materials as well?
Okay, and then there's another question from Amanda that says, how do you maintain the quality of products when switching from virgin to recycled plastics?
That is, I'm glad, Amanda, you asked that question, because in our granulation line, when the plastic is being melted, we have an instrument for adding additives to the recycled plastic. In virgin plastic, they put additives like antioxidants. And now we are able to restore the level of antioxidants. So what they do in the plastic, the antioxidants sacrifice themselves, so the polymer chains won't break. So that is the way we make the quality higher.
Okay, so through the use of additives that you're adding to virgin plastics in the recycling process.
We add additives to the recycled products because the virgin plastic were once they once used it in the virgin plastic, then it's used during the plastic lifetime, and then we are restoring it.
Okay. So adding the additive that has diminished through the initial use.
Yes.
Okay. And then we have a question here from Samuel that says, I may have missed this part, but I wanted to know a bit about the carbon footprint associated with recycling plastics. I know you mentioned in yours that it totaled about 5 kilograms of CO2 that's saved in total. Is there any CO2 emissions from recycling plastics? What is the energy consumption? Are there any waste streams from recycling plastics? What is the market that you supply the recycled plastics to? Is it only in Norway and Sweden, or does the recycled plastic reach further?
That was a lot of questions.
Yes.
I will start with what I remember. Plastic producers, we have a goal that plastic used in Norway are being dealt with and recycled in Norway, and then being used in new plastic products in Norway as a way to reduce the carbon footprint. But today, Norwegian producers are not ready or willing to use that much recycled plastic. So to make our business work, we have to sell plastic to other companies in Europe as well. And you had some questions about
the carbon impact.
Yes. The carbon impact, the numbers I showed in my presentation, it's calculations made by NTNU and Zero. It's a part of NTNU in Norway. But of course, we have emissions running machinery here. There's emissions related to transporting the plastic, but it's better, and it's a lower carbon footprint by recycling it than, for example, incineration. And it's a much lower environmental footprint than putting the plastic into landfills.
Certainly, and even existing in the environment does produce greenhouse gases as well with sun exposure. I believe it was a document published by WRAP, a UK company, WRAP, that sort of classified the various end-of-life options for plastic and noted that recycling had the best environmental impact. So just in terms of the markets that you mentioned, you indicated that you're currently expanding, which is wonderful to hear, especially with with finding different alternative end-of-life uses for the waste, as well as the carbon impact. So that's mostly to European expansion. And is there any area for growth to supply the products back to the aquaculture industries that you get your primary feedstock from?
Yes, we have. I hope I understood your question right. But a company named Plasto in Norway, they make these walking fields that goes around the whole aquaculture facility out of recycled plastic from the aquaculture. And we are also in a project with a company called Aqua Group, which is a huge dealer of these aquaculture facilities, and we want to produce a new aquaculture facility out of recycled products from an aquaculture facility, just to show the quality of our recycled products and try to identify what do we need to do with the recycled plastic to meet the standards.
Okay, certainly. And it seems like a very good step towards circularity in that the plastic that you're getting from the aquaculture industry goes back into use in the aquaculture industry.
Yeah.
Then we have a question from Carl, who I believe has a few people joining with him, saying, have you considered creating in-house products rather than recycling with other product producers? I'm assuming that's used. Sorry, go ahead.
No, we haven't. We have no plans on making plastic products here at our facility, because we want to be as good as possible at the recycling part. That is our main goal. And then the plastic producers who knows the production has to be best at their part, tuning their instruments for using this recycled products. So no, we're not making any products here at us.
Okay, then we have a question from Fiona that says, the definition of nets as dangerous waste, is this due to the salt brine content, or is there another reason that you refer to nets as being considered dangerous waste?
Yes, the nets used in aquaculture is being impregnated. They use a coating with very often copper, and they use it to prevent the nets from being filled with biomass. Because if that happens, there will be no oxygen for the fish inside the cage, so the fish will die. So they have to use this this coating. And when they take the nets out of the sea, because of this coating, it is characterized as dangerous waste. And then we can't recycle it. There are some people, some companies trying to wash these nets, but it's processes in need of a lot of energy to get the coating out of the nets. So what we do, we collect the nets and take them here. We cut them and we grind them into 2 centimeter pieces, and we send them to a company called Norway here in Norway that use these nets in their ovens instead of coal when they produce concrete. So in their ovens they use these nets instead of coal.
Okay, so not the same as incineration, but still being burnt essentially.
Yes, it's being burnt, but they are able to use up to 97% of the energy. Okay. And in addition, Norway has this carbon capture facility.
Okay, very interesting. Then there's another question that says, are the costs of what is produced more or less expensive than other plastic products, such as the bench? So in terms of the price, how does the recycled product compare to an original?
The plastic we produce, the granulates, are cheaper than virgin plastic. Okay. And that is, I think, an argument for many producers. They can produce products cheaper. But also, in addition, they get a good story and they get environmental benefits.
Certainly.
The price of the products, I don't know.
Okay. Can I ask, does that fluctuate at all with the oil price? So if the oil price sort of drops, for instance, is raw material not cheaper than the recycled content?
Yes.
Okay.
Yeah, and we have a goal that the price of our recycled products will be 70% of the virgin plastic. But then again, we need to get the quality up. The higher the quality, the higher price we can take.
Okay. I see. Okay, and then there's another question from Carl that says, from a producer's perspective, are your recyclates more or less expensive? Sorry, it was referring to the price. Sorry. Then there's another question that says, has Norway considered a leasing model where the producers of fish cages lease the cages to fish farms and have an extended producer requirement to organize the disposal?
Yes, and extended the producer, what did you call it?
Responsibility?
Responsibility.
Yes.
Are coming. And the producers are very eager to cooperate with us because they will be the one having to deal with the products when it's waste, and they want us to help them with that.
I see. Okay, so a whole other market when producers need to start considering the end of life uses for. So a whole other whole other range for recycling companies to expand into. Then sounds like. Okay. Then we have another question that says, thanks for your response and presentation, Tormod. We are facing many similar challenges recycling fishing gear plastics in the UK. Great to hear about your work. And then there's another question from Carl that says, do you have a sense of what percentage of plastic waste in Norwegian aquaculture is currently recycled? Is there some way we can find more information about this?
Today, I have to think, but I think we are recycling up to 70% of the ocean, the plastic from the aquaculture and fishery. It's mostly the nets that not being recycled today, and for someone it's they think it's better to put it in landfills because that is a much cheaper alternative.
I see. But so that would purely be a cost factor then, not considering the necessarily impacts in terms of space as well as carbon footprint then, I'm assuming.
The price of putting plastic in landfill should be extremely high, I think.
Certainly, particularly to make sort of alternatives, recycling and sort of more circular models more appealing and more viable in many communities. I just wanted to come back. I see it is 12 o'clock. I imagine some of our participants may need to leave, but just to come back to the question that you posed in terms of the circularity of the model, were you referring to the sort of the trade-offs between the impacts of shipping nets around the world to be reused when there might not necessarily be an end of life market for the nets there? You mentioned Malaysia.
Yes, I would like to have a tool that tells me what is the best, because reuse in a circular economy, reuse is better than recycling. But is it better when you have to ship it all around the globe? And is it better if there are no proper waste facilities in the other countries receiving these plastic products? So it's hard weighing all these sustainable goals.
Yes, definitely. It's almost necessary for there to be sort of a decision-making framework for, particularly in cases like that, because shipping, obviously, sort of your reduce, reuse, recycle will and repair and the various R's that fit in amongst that. Obviously, those would be your primary goals, but there would also be an environmental impact of shipping your nets halfway across the world for it to potentially then have to come back to be recycled further, and that would also further complicate extended producer responsibility schemes. So SST is working to develop action plans, so sort of how best to deal with your waste as well, particularly sort of accounting for scale as well, as you mentioned. There has also been a comment in the chat from Amanda that says, if I may, there's an excellent study by Deshpande et al. On material flows in the fishing industry, using material flow analysis to generate the evidence on plastic waste management from commercial fishing gear in Norway. I believe that's Paratosh Deshpande. He also presented a webinar for us 2 weeks ago. I believe that's the same one. Amanda, I'm not too sure if that's in reference to the particular question that Tormod raised, but if you could maybe sort of expand on that in the chat, that would be wonderful. Then we do have another question from Kieran that says, can the nets treated with anti-fouling be recycled for fish farm nets rather than being incinerated?
One more time.
Can the nets treated with anti-fouling, so I believe that's the copper that you spoke about to stop the biological material growing on the nets, can those particular nets be recycled for fish farming nets rather than being incinerated? So perhaps repurposing them for a different use rather than shredding them to go to the cement kilns?
Yes, most of the nets are nylon, PA plastic, and it's possible to make new fibers out of these nets, but there are no company in Norway producing these fibers. There are companies in Slovenia, I believe, but we are not allowed to export dangerous waste.
I see. Okay, so the nets couldn't be sort of pelletized and then shipped to be fiberized and made into new nets then because of the sort of shipment bans?
Yes.
Okay, so there are no companies in Norway that produce fishing nets from previous fishing nets?
No.
Okay.
Only virgin plastic.
Okay, interesting. We have another comment from Philippa that says the reuse versus recycle nets in a circular economy in this instance is very intriguing. Could the reuse of nets in other countries also lead to the accidental creation of invasive species, or are they treated to prevent this?
I don't think they are doing anything to prevent that.
Okay, would the copper treatments have any sort of impact on that, or could the nets still act as a vector if they're transported to different waters?
I don't know.
Okay. Okay. Very, very interesting point raised there. All right, then I see Amanda did add to her earlier comments saying was that her paper suggestion was with reference to Carl's question about the proportion of nets that are recycled, and it also estimates quantities going to repair that leak into the marine environment. I don't see any other questions here at the moment, but if anyone does have any questions in the future, you're welcome to email us at webinars@scafrica.org.za, and we'll happily pass those along to Tormod. For now, I think we can close off today's session. I see we are slightly over time, but there were plenty of questions, and it's very, very interesting to hear about the work that you're doing. So on behalf of all of us at SST, thank you so much, Tormod. It was wonderful to hear about the work that Oceanize is doing, and it sounds very encouraging, particularly for end-use markets, the carbon cost saving, as well as the fact that you're expanding. So it's been very interesting.
Thank you.
Okay. Thank you so much, Tormod. I see there are plenty of comments coming through in the chat as well. So I think we can close off the session here for today. We hope to see you all again next week. We will be having another speaker from Norway, Betty Cormier, who will be speaking about microplastics and the research happening at NTNU. So we look forward to seeing you all there. The registration link for that can be found on our SST events page, and we hope to see you all there. And again, thank you so much, Tormod. We really appreciate the time that you took to present for us today, particularly in English. So we really we really value your time this morning.
I'm sorry if I misspelled something or couldn't find the right English words, but hopefully you all understood my points.
Oh, definitely, and very, very interesting. So, and as I say, I'm sure your English is far better than most of our Norwegian. So, we really appreciate that.
Okay.
Okay, wonderful. Thank you so much, everyone, and we hope to see you next week. Enjoy the rest of your afternoons and your Wednesdays. Thank you.
Bye.
Bye bye.